In this example, we have 3x over x minus 2 minus 5 over 3x plus 3. So since we have rational expressions, meaning expressions in the denominator, you always check if you can factor. In the first fraction, x minus 2, the only thing that is in common between these two is just 1. That means that x minus 2 is in its simplest form. That will be its simplest factor. Now in the second fraction, we have 3x plus 3. So we have 3 that is in common with the two terms, so I'm going to have to factor this by GCF. So I'm going to rewrite it as 3x over x minus 2 minus 5 over, here we're going to have 3 parenthesis x plus 1 close parenthesis. So I finished factoring the denominator in the second fraction, which is 3 times x plus 1. Now let's formulate our LCD. Alright, I want to identify if we have any single numbers, which we do, the 3, so I'm going to put the 3 first. Now, in the second fraction, it has the x plus 1, so I'm going to include the x plus 1. That's a separate factor. In the first fraction, it has the x minus 2, so I'm going to include that in the LCD. So I finished getting all the factors and formulating our LCD, and I'm going to keep it in this form. And this will be the final form that you're going to use in the final answer. Now let's compare the denominators with the LCD. In the first fraction, it has the x minus 2, so I'm missing the 3 and the x plus 1. So I'm going to multiply the numerator and denominator by the missing factor, so the 3 and the x plus 1. Then checking the second fraction, it has the 3 and the x plus 1, but it's missing the x minus 5. So I'm going to multiply the second fraction by the 3. Sorry, not the 3. It already has the 3 and the x plus 1. I'm just going to multiply the missing factor from the LCD, which is x minus 2. Alright, so comparing the denominator, we have a 3, we have the x plus 1, we have the x minus 2, so I'm going to combine as one big fraction. I'm going to have 3 times x plus 1 times 3x minus, now I'm going to put the 5 in parentheses, and it's multiplying to the x minus 2 over my LCD, which is 3 times x plus 1 times x minus 2. Alright, I'm going to do this step by step when I'm multiplying in the numerator. So here, I'm going to distribute the 3 to the x and the 1. So I'm going to have 3x plus 3 in parentheses multiplying with the 3x minus, now here I'm going to distribute the 5 to the x and the minus 2. So I'm still going to have parentheses. 5 times x is 5x, and then 5 times negative 2 is negative 10. Close parentheses over my LCD. Alright, I'm going to keep simplifying. So here I have the 3x. I'm going to distribute to the expression that's on the right side. So I'm distributing the 3x to the 3x and the 3x to the 3. And I'm going to write out here for more space. So 3x times 3x will be 9x squared. 3x times 3 will be positive 9x minus, now here I'm going to distribute to the 5x and the negative 10. So again, I'm distributing the minus to the 5x and the minus 10. So the negative to the 5x will be negative 5x negative to the negative 10, well, this will become a positive 10. So this part, it changed sign. So that's why I said be very careful when you're working with subtraction. You're going to be distributing the minus to the parts that's inside the parentheses. So this is why I have included parentheses when we are trying to find LCD, getting common denominator, combine it as one fraction. You can see here, with this minus, you're going to distribute to all the parts inside. This part right here, negative to negative 10 became positive 10. So you want to be extra careful. You want to have the right sign, so when you combine like terms, you get the right answer. And then I'm going to write my LCD, 3 times x plus 1 times x minus 2. From there, I'm going to write my final answer because I can combine like terms in the numerator. I'm just going to have 9x squared, and I'm going to combine positive 9x with the negative 5x, meaning 9x minus 5x will be positive 4x, and then plus 10 over 3 times x plus 1 times x minus 2. So I finished combining terms. I'm going to check if I can combine simplify the fraction. And as I am examining each part, the 3 parts I have in the numerator and the LCD, there is nothing in common, no same number, no same variable that I can simplify. So this fraction is in its simplest form. I'm going to box it, and our final answer is 9x squared plus 4x plus 10 over my LCD, which is 3 times x plus 1 times x minus 2. In this example, I have 5 over 2 minus n minus 5 over 2n squared plus 4n. So since I have an expression in the denominator of the second fraction, I'm going to check if I can factor it. In this case, I can. I'm going to factor this by GCF. So what's in common is the 2n. So I'm going to rewrite this. So it's going to be 5 over 2 minus n minus 5 in the top, and the denominator, it will be 2n parenthesis n plus 2 close parenthesis. Next, let's formulate our LCD. Now if I compare the two denominators, they both have 2, so let's include that in the LCD. Now what's missing from the first fraction, but that we have in the second fraction, is the n, so I'm going to include the n. And then I'm going to also include n plus 2, so n plus 2. So that's my LCD, and basically this is the final form that we can use in our final answer. So now, let's compare each denominator with the LCD and see what we're missing. So in the first fraction, we have the 2, but we're missing the n and the n plus 2. So I'm going to multiply the numerator and denominator by the missing factor, so the n and the n plus 1. Now in the second fraction, we have the 2, the n, and the n plus 1. So that means that we don't have to worry about trying to convert to same denominator because it has all the factor. But for good practice, I'm going to put the numerator in parentheses since it's in the expression and we're working with subtraction. And you'll see why I put this in parentheses. Now comparing the two denominator, it has the 2, it has the n, and it has the n plus 2. Now let me fix this. I don't know why I wrote n plus 1. It should have been n plus 2. Alright, so again, double checking my denominator. It has the 2, it has the n, and it has the n plus 2. So we're good. Let's combine it as one big fraction. So n times n plus 2 times 5 minus parenthesis n minus 5 over 2n times n plus 2. Alright, for this example, I'm going to take it step by step because we want to be very careful when we are working with subtraction. So here, I'm going to distribute my n to the n and the n plus 2. So I'm going to have n squared plus 2n in parentheses with the 5 minus parenthesis n minus 5 close parenthesis over my LCD 2n times n plus 2. Next, I'm going to distribute the 5 to the n squared and the 2n since they're multiplying to each other. And then I'm going to write on the right side for more space. So when I distribute the 5 to the n squared, I'm going to have 5n squared, 5 times 2n, the positive 2n. So it's going to be plus 10n, and I don't need parentheses anymore, minus n minus 5 with the parenthesis over my LCD 2n times n plus 2. Now what's different with this example compared to the previous example is now I'm going to distribute my minus to the n minus 5. Now if you compare to the original problem, the original example, here you see it's minus and then n minus 5 at the top over 2n squared plus 4n. Since the numerator is an expression and we're working with subtraction, again, you saw how I put parentheses on the n minus 5. The reason I want to do that is because since we have a minus, I'm actually going to distribute the minus to the n and the minus 5. So again, I put parentheses so that way you can visually see, and it would be a reminder that, alright, I'm going to distribute my minus to the n and the minus 5. In the past, I have students that either forgot to distribute to the parts that you see in the numerator. Since I have multiple parts in the numerator of the second fraction, they forgot to distribute the minus, or they only distribute to the first part, but not to the other respective part that's with the numerator of the second fraction, or basically what's inside the parenthesis. So again, I include parentheses so that you can visually see, and it's a reminder that, alright, I'm going to distribute my minus to the n and the minus 5. So the first part, 5n squared and the 10n will stay the same. Now I'm going to distribute my negative to the n, that would be negative n. Distribute my negative to the negative 5, that one will become plus 5, so it changed sign, over the LCD 2n times n plus 2. Now I'm going to combine like terms and make my final answer. Now the only term I can combine is the 10n and the negative n. So I'm going to have 5n squared. 10n minus n will be plus 9n and then plus 5 over 2n times n plus 2. So that's going to be my final answer because I finished combining terms. There's nothing I can simplify because in my three parts of the numerator and my LCD, there's no common number that you can simplify, no common variable that you can simplify. So this fraction is in its simplest form. So I'm going to box it. And my final answer is 5n squared plus 9n plus 5 over my LCD 2n times n plus 2.